Okay, so climate change. There's going to be some extra information in this one. I know the book briefly mentioned it, but I wanted to put a little bit more in there because I don't think people really understand what climate change is all about. And I think it's one of those hot topics that we really should be discussing more. So what I notice is people really confuse climate and weather. As I mentioned before, all biomes are affected by global conditions, the amount of sunlight, the amount of precipitation you get. Now, climate is your long-term weather conditions that are in that environment. And it's going to be the history of weather over a long period of time. So it's years and longer. I've only lived in Texas my own life, and I'm kind of used to this climate where it's kind of not as cold in the winter, but the summers are just painful, but we can deal with it because we have AC. But then you go up north, they can deal with the ice that we can't, but then when it gets above 85 degrees, they freak out. Everyone has different climates that they're adapted to. Now, this is a little bit easier to predict the outcomes because you kind of know what to expect your seasons are going to be like. Now, weather's over short periods of times. It could be hours, days, or weeks. We're at that time of year where it's freezing at one point, and then it's hot at 4 o'clock, and then sun goes down. It goes down 15 degrees, and it's miserable. Very difficult to predict. Now, the main contributor of all this is your good old sun, and depending on where you are on the globe is determined the amount of sunlight that you're going to get. So remember, the good old Earth, she is on an axis. So right now this is typical to where we are. So we are getting that lower angle of sunlight, so that's why we get those cooler temperatures. If your axis is facing towards it, you're getting more, so that's why we have the hotter summers. So this just shows you the different zones and the amount of sunlight. So remember, as I mentioned, we have a lot of diversity within the rainforest because they get the most amount of sun. And that's why those areas have a lot of light streaming in them. So the greenhouse effect is something that is really driving climate change. So what solar radiation does is going to drive the climate, and we're going to get radiation from the sun come, and then we have the atmosphere that surrounds the earth. Now it does filter out a lot of solar radiation. So it comes through and some of it bounces off and goes back and is reflected into space. Now our atmosphere, which is great, think of it kind of like a blanket. It surrounds us and it keeps some of that radiation in, so some of it does get bounced back in, which is good because if not, it would be freaking cold at night and we would not be able to survive. Oceans are great for that because they do absorb a lot of heat, and then they kind of refract that heat during the evening hours, and that provides some heat to help us conflict the absence of sunlight. Now, the greenhouse effect is when we have these excess gases, and what they do is it's like putting on another blanket on top of it. So when the greenhouse gases is when we have the water vapor, CO2, methane, and ozone all come together. So we have the nice light blanket, which is our atmosphere. Let's put a down comforter on top of that. So when that happens, we can't reflect as much radiation back into space, much of that heat. So that heat gets trapped in, and now that heat gets trapped back into the atmosphere and just goes back to Earth. Now, if we can't get rid of that, that means we have to absorb that excess heat. Now, there's different patterns based off this. I know this looks super confusing. I was a weather buff when I was little. I wanted to be a meteorologist when I was a little kid. I'm such a science nerd. I really am. But for a while there, I wanted to go to weather girl school, and I just don't know why, but I did. So depending on the patterns of where you are from the equator, you're going to have what we call these thermal cells. And you can see they have like a circulation pattern too, and it has to deal with how the Earth rotates and everything too. So with the Earth's rotation and then all these different patterns, we have what's called the Coriolis effect. So this is why you see, like when you see, especially when it was hurricane season, you see these disturbances come off the trades of Africa, and then they'll go into the ocean, and then they'll eventually become tropical storms and go into the Atlantic or the Gulf and all the other stuff. And how they always circulate this way, it has to do with the Coriolis effect. Especially, it's kind of different when you get down to there. That's why you see, depending if it's a cyclone or a hurricane, the way it's going to turn. Now, these polar cells too are going to influence a lot of the weather patterns that you're used to seeing. So, like when you see the fronts and stuff, it's because it's coming down right here, air moving up around these different cells. So these winds are really going to be important for like the different biomes we have, because it's going to be moving different climate and weather patterns. Now, in addition to the air moving around, the ocean has a key role too, okay, because we actually have this like current system that goes through all the oceans. And what it's doing, it's moving warmer water to the cooler areas and causing heat to be released. And that water cools down and brings colder temperatures and kind of cools that down. This current is called the thermohaline circulation. Sorry if I said that right. It also mixes the salinity of water up too. It's a global mixing, and I always think of, you know, Finding Nemo and the Crush, where they like ride the current jet stream all the way through. So it kind of makes you think about it, but this is another way that we're mixing water temperatures too, so which might really influence some of these, especially those ecosystems that you find in the shallower waters. So there's a big debate, is climate change real or not? So climate change is just a changing overall global temperature. So people debating, oh, it's not real, not real. This is a group by that Kuznak Science where it talks about it. I love them. You probably had to watch multiple videos from them, and it's just a good one. Share this with your family, because I love it, because they make it in terms anyone can get to. Now, as we started burning more fossil fuels, we started to introduce more carbon dioxide into the atmosphere, and we're able to measure this. And yes, we do have where we have these cycles of where over time where it gets warm, then it gets cold, warm and cold, and warm and cold. And we are at this point where we're naturally seeing that we're increasing a lot of CO2 in the atmosphere. Now, how do we know how things were in the past? Well, we actually go through and look at ice cores. So what they do is they take samples of polar ice, and they can measure air trapped in bubbles and get a temperature and CO2 levels. So this is a video that kind of goes through that. Now, as I mentioned, we do have these cycles, but I think we're kind of entering where we are breaking one of those natural cycles and entering one where it's man-made and we can't control it. So about right now, so remember I was talking about cycles on the previous slide. Well, with the increase of the Industrial Revolution, we're seeing more and more CO2. So as we keep burning more fossil fuels and using the cars and gas and all the other stuff, we're starting to see CO2 levels go up. One thing I thought was cool is you can actually look up the numbers for different times. So this is a website, you can click on it, it's updated daily. So when I was making these slides, I made this one October 12th, 2020. And for that level that day, it was 410.89 parts per million. And you can look for previous years. So I did the previous year, it's 408. I'm recording this lecture on December 1st. Yes, it is December 1st, 2020. And I just looked up. It is, for yesterday, was 414.36, so it's higher. So this is one way that we can actually say, okay, it is going up. I think it's measured in Hawaii. So yes, we are contributing to it. We think human contribution is a big one, but there is some natural things. So we have what's called the Milankovitch cycles, where there's a slight change in the Earth's orbit, and it happens between every 19,000 to 100,000 years. I don't know when the next one's supposed to happen. It's just something that was briefly mentioned before. And then we have solar cycles. The sun goes through phases too, and there are times where we have like a higher cycle than lower ones, and it can change with sunspots and flares and other things. Volcanic eruptions can also influence things, because if it's a big one, it can release a lot of stuff into the air between carbon dioxide, vapor dioxide, hydrogen sulfide, hydrogen carbon. And depending on how big the eruption is can really have an effect, because it can create a haze in the air and actually influence things. Now, the one that really breaks my heart is what we're seeing currently. And you hear about this all the time. A lot of our glaciers, where a lot of fresh water is stored, are melting at an alarming pace, and especially ice sheets in Greenland and the Antarctic. This is really concerning, because these are things that we've actually seen in our lifetime go down. And as this ice melts and warms up, it has to go somewhere, so it's going into the sea. That's causing sea levels to rise. So we're starting to see sea levels rise a little bit more. It used to naturally rise about 1.8 millimeters per year on average. Now it's up to 3.4, and you think that's not much, but You know, watch this video. It talks about rising sea levels and amount of population that live in these low-lying areas. So really good watch. And this just breaks my heart because you just see the sad polar bear picture. You know, if he's losing his environment where he lives because the ice is melting, what's going to happen to him in the long term? So hopefully that wasn't too depressing. Here's some more cool videos on climate change and weather in general. And then, of course, credit for my sources.